So in this video, we are going to compare the similarities and differences between the right triangle, and right triangle is a triangle with the right angle, which is 90 degrees, and the unicircle, which is a circle with the half of the diameter, the radius as 1. And when we're dealing with the trigonometry or a trigonometry function, which we're going to talk about right now, the trigonometry has two traditional approaches for defining it. Firstly, when you're thinking about the right triangle, we are thinking of the ratios, the proportion between the special angles that we talked about in the previous videos, as well as the sides. And when we're thinking about the unicircle and apply it to trigonometry, we are dealing with the angle rotations as well as the measurements with the coordinates as x, y, because we're thinking of that in terms of the coordinate plane, as well as the trig values such as the sine, cosine, and tangent. So there are basically two types of ways for approaching the trigonometry, and both of them will lead to the same function because they are both ways to define the trigonometry. However, they have their own pros and cons when we're dealing with the special or particular types of the trigonometric questions. So for a right triangle, let's start off by thinking an example for the triangle that has the main angle, which is the central angle, as pi over 6. And pi over 6 is radian measurement to express 30 degrees in terms of degrees. So if there is an angle measurement as a central angle here, that is pi over 6, another way to say 30 degrees, then we already know the ratio between its sides. The hypotenuse, that is the longest side, is 1. The 1 over 2, that is opposite side with our pi over 6, main angle is 1 over 2. And the angle measurement that is adjacent to our pi over 6 is square root of 3 over 2. And from here, we can define all three trig functions as the sine of our main angle, 30 degrees, or pi over 6 in terms of radians. Secondly, we need to solve the cosine of our pi over 6 main angle. And thirdly, we want to define the tangent of our main angle, pi over 6. And we already defined the sine of our pi over 6 as 1 over 2, and cosine of pi over 6 as square root of 3 over 2, and tangent pi over 6 as 1 over square root of 3 in our previous video. And if you're not familiar with this concept about the right triangle ratios and the special angles, then you need to go back to my previous videos about the right triangle ratios between sides and angles and how to memorize them. So we define the sine of our main angle pi over 6 as 1 over 2, cosine of our main angle pi over 6 as square root of 3 over 2, and tangent of our pi over 6 as 1 over square root of 3. However, this only happens when our main angle is an acute angle. The pi over 6 is an acute angle, that is an angle less than 90 degrees. What about the next example where the main angle is an obtuse angle that is greater than 90 degrees, such as 135 degrees? So this is a triangle with the main angle or the central angle as the 3 pi over 4. 3 pi over 4 is a radian measure to measure the 135 degrees in terms of degrees. So this is the 3 pi over 4, and 3 pi over 4 is obviously an obtuse angle which is greater than 90 degrees, or 135 degrees, another way to express it. However, when we're thinking about the obtuse angles, there is no clue for us to define the three trig functions. So the first thing we want to solve is what is the sum 3 pi over 4, and the second one is going to be what is the value for the cosine of 3 pi over 4. And the third one will be the what is the value for the tangent of 3 pi over 4. However, we have no clue what these values are. We don't know what the sine of 3 pi over 4 is. We don't know what is cosine of 3 pi over 4 is. And also, we don't know what is tangent of 3 pi over 4 is. So we could figure out that the angle rotations that are possible inside our right triangle. Inside our right triangle, the only possible outcomes for the angle rotation is 0 to 90 degrees. So 0 to pi over 2 radians, which is 0 degrees to 90 degrees. So this is the only domain we can measure inside our right triangle. However, as we expand the trigonometric ratio into a function, which is going to be a trigonometric functions, which we're going to talk about more detail as we learn the trigonometric function. In the basic graph for trigonometric function, the x value and the y value will approach infinity. Therefore, we are going to apply a new type of measuring angles, which is going to be a unit circle. And that's why we apply a unit circle to our trigonometric functions. So we cannot use the right triangle inside our trigonometric function, we can only apply it inside our right triangle ratios. So now, as we expand our notion to the trigonometric functions, we will apply the unit circle. So let's erase these two types of the angle measurements inside our triangle and think more detail about the unit circle. And before we do the unit circle, the most thing we are going to talk about is the radians. And if you don't know how to convert the radians to degrees or degrees to radians, such as 3 pi over 4 is 135 degrees, or pi over 6 is 30 degrees, we will have a hard time while solving the trigonometric function problems. So if you're not familiar with it, you need to go back to my previous video about the introduction to the radians and how to convert them. So let's erase these two types of the angle measurements inside our triangle and think about the unit circle. So this is a basic setup for a unit circle. And again, the definition for the unit circle was originated from the word unit. The unit circle is a circle with the radius, and again, the radius is half of our diameter of 1. So with the half of the diameter of 1, we'll be able to define all trig angle rotations and the measurements. So again, we're thinking about the unit circle on the current plane x and y. So we need to think about the basic setup for it. So we can think about the quadrantal angles, which are the angles that we are pointing right now. And firstly, those are going to be the main angle rotations that will help us also graph the trig functions. So here, when the angle rotates 0 degrees, we write 0. And as it rotates to 90 degrees from the starting line and get to this point here, which is the intersection between the y-axis and the circumference of our circle, then we write it as the pi over 2. And again, the pi over 2 is a radian form to express the 90 degrees. Now what if we go the 90 degrees even more? If we go 90 degrees more, when we reach the total 180 degrees, then the point here, that is the intersection between the negative x-axis and the circumference of our circle, we write it as the pi radian. And pi radian is to say the 180 degrees angle rotation in terms of degrees. And if we rotate in 90 degrees more from 180 degrees, where we rotate 270 degrees, we write it as, in here, it will be 3 pi over 2. And 3 pi over 2 is 270 degrees in terms of degrees. And lastly, if you get back here, we will write as the 360 degrees, or another way to say 2 pi radian. So the 2 pi must go in front of the 360 degrees. The 2 pi radian, another way to say 360 degrees. And as it rotates 360 degrees, one period or cycle for the angle rotation has finished. So this is the basic setup for our unit circle. And the another most important thing that we're going to talk about is the coordinates of this quadrantal angle rotations, because we're thinking of it in terms of the coordinate plane. So firstly, obviously this point here, if the radius is 1 in our unit circle, that means this length is also 1, this length is 1, any kinds of segments from the circumference of our circle all the way down to the axis or the origin, will be positive 1. And that means also if you make a straight line from this origin, such as this segment, that will also become the length of 1. And this is a basic setup. That means this length here, the purple line, will be 1, 0, where x is 1 and the y value is positive 0. If you go to 90 degrees and reach pi/2 radian, then the coordinate for this point will be 0, positive 1, because we already know that it is on the positive y-axis, where the x must be 0 and y value must exist. If we travel the angle 180 degrees and reach here, then the angle rotation will be -1, 0, since we know that the point is on the negative x-axis. And lastly, this point where we rotate to 70 degrees, that will be equal to 0, -1, because the point is the intersection with the circumference of a circle and the negative y-axis. And this is the basic setup of our unit circle on our coordinate plane x and a y-axis before we do any things about the unit circle and the angle rotations. And when we're thinking of the unit circle, there is one special definition we define inside our unit circle. And that definition, which I'm going to explain more in the next video about the types of the angle rotations. Let's say there is a terminal like this. And let's say the central angle is theta, which rotated the counterclockwise positive directions. Then if we make a right triangle inside our unit circle to think about the coordinate for the x and the y, we can realize that the hypotenuse of this triangle, the right triangle, is always going to be 1, just because I explained the definition of the unit circle, where the radius is equal to 1, and the x value all the way from here to here will be the x value, and from this point on the circumference of a circle all the way down to the point on the x-axis will be the y value. However, we can think about the 3 trig functions. So firstly, the first thing we're going to talk about is what is our sine of our main angle theta. Well, if you don't know this, and I'm going to use the technique I used in the previous video about the angle rotations, about the right triangle ratios between sides and the angles and how to memorize them. And if you're not familiar with it, you need to go back to my previous video and think about it. For this sine, it always starts off the hypotenuse of our right triangle and will go all the way down to the opposite side of our theta, which is our mean angle. So if you think about it in terms of the ratio where we are going to define in terms of fraction, the denominator part will be the value where we start off, and the numerator will be the value we finish off. So we again in the right triangle, we always start off the hypotenuse 1, and we finished at the opposite side of our mean angle y, which eventually will give us the value of the y. And that means inside our unit circle, the sine of our main angle, any main angle will give us the value of y. Now let's think about the second thing. Second thing to talk about is what is our cosine theta. Well, for cosine theta, we always draw C, always start off the hypotenuse and along with the angle that goes all the way down to the adjacent side of our main angle. And this is C for the cosine, how to define it. So again, the C always start off the hypotenuse and will go all the way down to the adjacent side of our main angle. So again, if you're defining it in terms of the fraction, we start off the hypotenuse, which is 1, and we finished at the value x, which is adjacent side of our main angle. That will give us the value of x. That means inside our unit circle, the cosine of our main angle theta will be the x value. Now using this proof, we can realize inside our unit circle, and this only applies when we're thinking of the unit circle inside our trig values. The first thing we need to remember is the sine of our any data, any angle measurement data, will be the y coordinate. Secondly, the cosine of our main angle is going to be the x value. And these are the things that we're going to talk about more detail in the next videos. And so all you have to remember is sine of any angle is y value inside either unit circle, and cosine of any angle would be the x value or the x coordinate. So we can rewrite the coordinate for this point here, where the x is x and the y value is y, as the cosine of our mean angle theta, comma the sine of our mean angle theta, where the cosine theta is our positive x value, and the sine theta is our positive y value. And this is the basic definition that will define in our unit circle. And let's get started after erasing all of this expression, and start with the first angle rotation in our unit circle. So now let's assume that the angle that rotated from the positive angle rotation counterclockwise direction theta is pi over 6 radian, which in this case in terms of degrees is 30 degrees. Then we can realize to define the x and the y value, we can figure out that the mean angle is pi over 6, where we can actually apply our trigonometric ratios. And we already know that the hypotenuse will always be equal to 1 for the ratio. The value that is adjacent with our mean angle will be square root of 3 over 2 when the mean angle is 30 degrees. And the side that is opposite with our mean angle when it is 30 degrees is 1 over 2. Then we can realize that the x value, which is cosine theta, is square root of 3 over 2, and the sine theta, which is y value, will turn into 1 over 2. That means the cosine theta and the sine theta, the theta value has its actual value as pi over 6, which is radian. Cosine of pi over 6 and the sine of our pi over 6, where cosine pi over 6 is notated as the square root of 3 over 2 using our right triangle ratios. The sine of pi over 6 value is y value, which is 1 over 2. And this will happen when our mean central angle here, theta, will be equal to pi over 6, 30 degrees in terms of radian. Now let's think about the next angle rotation, which will be 45 degrees, exactly half of our 90 degrees, like this. So this is a case when our mean angle, central angle rotated total 45 degrees, pi over 4 radian, which is 45 degrees in terms of the degree term. When it rotates pi over 4, we want to figure out what is this point, which is also going to be the cosine and the sine value. So in order to think about it, let's make a small right triangle, because making a right triangle is a way to define the value for the coordinate. Then automatically there will be the right angle right here. And if you're thinking about pi over 4 radians, then we can realize that it is one of our right triangle ratios, where the side that is opposite with our mean angle, which is this side right here, will be square root of 2 over 2. And the side that is adjacent with our mean angle, and let's move this square root of 3 a little bit right side. And if you call this as the square root of 2 over 2, which means this side and this side are exactly equivalent together according to the right triangle ratios. That means the coordinate will be square root of 2 over 2, comma the positive square root of 2, comma 2, where the square root of 2 over 2 inside the x value is the cosine value. It is the cosine for our mean angle, pi over 4, and the square root of 2 over 2 inside the y position is going to be the sine for our mean angle, pi over 4 radian. And this is how we define the trig values inside our unit circle. So this will happen when our mean angle is pi over 4 radians. And again, because of the definition of unit circle where the radius is 1, then the square root of 2 over 2, which is cosine of our pi over 4, will be our positive x. And the square root of 2 over 2, which is the sine of our mean angle pi over 4, will be a positive y value. Now let's think about the last angle rotation in our first quadrant, which is the 6 degrees pi over 3 rotations from the positive initial line. So we rearrange the coordinate where this point x coordinate is square root 3 over 2 as the biggest x coordinate, and this coordinate for here is same with the y coordinate as square root 2 over 2. And right now let's think about the angle rotation right over here that rotated totally pi over 3 radians. So we rotated pi over 3 radian, which is 6 degrees in terms of degree form. And if you rotate 6 degrees, we want to find the x and the y coordinate for this point, which is essentially a x cosine and a y sine value. So again, if you make a right triangle like this, to think about the coordinate, then automatically the right angle will be formed here. And we need to find the coordinate here, but according to our right triangle ratio, if the main angle is 6 degrees, then the point, the side where which is opposite with our main angle, will be equal to square root of 3 over 2, and the side that is adjacent with our main angle will be 1 over 2. So we can realize that for this point, the cosine is 1 over 2, which is an x coordinate, and sine is square root of 3 over 2 as a y value. So this coordinate will be 1 over 2 comma square root of 3 over 2, where 1 over 2 is the cosine of our main angle pi over 3, 6 degrees, and square root of 3 over 2 is sine of our main angle pi over 3. And these were the 3 trig values where we could apply in our using our right triangle ratios in the first quadrant where x and y are both positive values. Now let's think about what if the angle rotations go over 90 degrees, such as 120 degrees. So this is the terminal line where the angle measurements from the starting line rotated 120 degrees, which is 2 pi over 3. And it is 120 degrees in terms of degree form, and we want to solve for the coordinate for this point, which is a point of the angle rotation of the obtuse angle. So for 2 pi over 3, which is 120 degrees, there are totally basically 2 ways of rating this point. And I'm going to explain the first way, and for the second way, we're going to talk about it in the next video, where we're going to talk about how to find the sine and the cosine of any types of angle rotation. The first way to do it is to make a right triangle just like this. And when you make a right triangle, then with the right angle, all you have to do is solve for the point for this point, which is pi radian 180 degrees minus the angle that we rotated, which is 2 pi over 3 radian, and that is going to be pi over 3 radian, which means all you have to rate is 60 degrees angle to solve for this coordinate. And the reason is because inside our trigonometric function, the exact values are different for them. However, we are trying to solve for the coordinate of this, where the coordinate, they share exactly the same coordinate. The x value, they share it as the same coordinate from here to here. They share the x coordinate from here to here, and they share exactly the same y value from here all the way to here. So that's why we could say that they share a common value of x and y. So in the 6 degrees, then the x value will be 1 over 2, and the y value will be square root of 3 over 2. And again, the hypotenuse will always be equal to 1. But we need to remember that this is a trigonometric function that has a special signs for each x and y value. In the second quadrant, the x should be negative, so it will be negative 1 over 2 with the positive square root of 3 over 2. So this point coordinate will be 1 over 2, but negative, comma, square root of 3 over 2. That means the negative 1 over 2 will be the value for the cosine of the total angular rotation, 120 degrees, 2 pi over 3, and square root of 3 over 2 will be the sine of our mean angle, 2 pi over 3. And this is how we measure the coordinate for the obtuse angle that is greater than 90 degrees. So next, think about the next point, the second point on the second quadrant, where we rotate 135 degrees like this. Before you do the 135 degrees angle rotations, in order to think about the cosine and the sine of our mean angle, the cosine and the sine of our mean angle, the cosine and the sine of our mean angle when the special angles is 60 degrees, 45 degrees, and 30 degrees, which are an acute angle. And in order to get cosine and sine, all you have to do is read those, the x and the y coordinates, to get each cosine and sines in of their special angles. However, if you get to the obtuse angle, for example, obtuse angle like this, which is 2 pi over 3, 120 degrees from the origin, 120 degrees. Also, in order to get this cosine and a sine of our mean angle, which is an obtuse angle, all you have to do is read those coordinates. And for reading that coordinate, there are basically two ways of thinking of it. The first way to think about it is to make a right triangle. Just like this. We're in coloring with the red color. And the people might think that why can't we make a right triangle that looks like this, where we're drawing in a yellow color. And this is possible to read the coordinate for our obtuse angle, to think about the cosine and the sine values. But this right triangle has a special meaning in the trigonometric function. So even though it's possible, we're going to use the first triangle in order to read the coordinate to get the cosine and the sine of our obtuse angle rotations. And we're going to talk about this second triangle in the next video. The next, which is the second last angle rotation in the second quadrant we're going to talk about today, is 135 degrees. So from origin all the way to here, it will be 135 degrees, and 135 degrees we rotate in terms of radian as 3 pi over 4 radian. I won't write the degree formats. And to think about this point, to rate the cosine and the sine on our unit circle, then we always need to remember that we need to make a right triangle. If we made our right triangle, then automatically we need to form a right angle. And this total angle is 3 pi over 4 radian, 135 degrees. But again, just like I said in the triangle with the angle rotation 2 pi over 3, to read the obtuse angle, we need to read this coordinate, this angle rotation, which is from the pi 180 degrees minus this angle rotation 2 pi over 3 radian, and that is going to give us 45 degrees as pi over 4. And pi over 4 shares exactly the same coordinate with the 2 pi over 3 radians, 135 degrees, which is this angle rotations. So again, when it is 45 degrees is our mean angle, then the y coordinate and the x coordinate will be exactly equivalent as square root of 2 over 2 and the square root of 2 over 2. However, we need to remember that this is a coordinate on the x and the y axis, which means in the second quadrant, the x value will be negative. So the coordinate for this point here, will be negative 2, square root 2 over 2, comma, positive square root of 2 over 2, where this negative square root 2 over 2 is our cosine for our central angle, 3 pi over 4, and the square root of 2 over 2 is the sine of our mean angle, 3 pi over 4, and this is how we define the angle measurements with the cosine and sine when the angle measurement is 3 pi over 4, 135 degrees. Now let's get to the next angle rotation, which is the last example on the unit circle, which is going to be 150 degrees. So we rearranged the x coordinate, and now let's think about the last one, which is this point. And let's say when the so if we erase this a little bit, let's say we rotated the angle measurements to the positive counterclockwise directions. So from here all the way to here as 150 degrees. And again, 150 degrees in terms of the radians that we generally use is going to be 5 pi over 6 radians. And this is going to be 150 degrees in terms of radians. And again, to think about the coordinate, we need to make a right triangle like this always. And automatically a right angle will be formed to show that it is a right triangle with the right angle. Then, just like I said, if here to here is 150 degrees, then again to read the coordinate of cosine and a sine to get cosine and sine from our coordinates, we always need to think about in terms of the acute angle like this, and this will be pi radian 180 degrees minus the angle which is rotated minus 5 pi over 6 radian, which is going to give us pi over 6 radian, and pi over 6 is 30 degrees. And we're going to read the 30 degrees for this triangle, and I will just express the x coordinate here. When it is 30 degrees, the x coordinate will be square root of 3 over 2, and the y coordinate will be 1 over 2. However, we need to memorize that on the unit circle, it will be the coordinate. On the second quadrant, the y value is positive, and the x value will always be negative. So if you write this coordinate here, so let's write it right here. The x coordinate will be negative square root of 3 over 2, and the y coordinate will be positive 1 over 2. And this means negative square root of 3 over 2 is the cosine value for our mean angle, which is 5 pi over 6, 150 degrees. 1 over 2 will be our mean angle for the sine of our mean angle, 5 pi over 6, 150 degrees. So again, to get the cosine and a sine value in our unit circle, all you have to do is read the coordinate. And this is the all 6 examples on our unit circle to think about the angle rotations, including the acute right angle and the obtuse angle. So if you review what we did here, because of the property where the unit circle has a radius of 1, every cosine value, so every x value and the y value, every x value and the y value has turned to just a cosine and a sine value. So if you want to rate the cosine value of our mean angle, all you have to rate is our x coordinate. If you want to rate the sine value of that mean angle, all you have to rate is the y coordinate. And another thing that I want to talk about is that if you want to measure the acute angles, all you have to do is just rate this coordinate to think about the x and y, cosine and a sine value. However, if you get to the obtuse angle that is greater than 180 degrees, not 180 but 90 degrees, we always need to think about it inside the acute triangle with the acute angle and the right angle like this always, because it's hard for us to rate the coordinate using our obtuse angle. And the reason why we could do it is because the obtuse triangle and the acute triangle that shares the same coordinate has the exactly same cosine and sine value for that coordinate. So we couldn't apply our right triangle because using our ratios between special angles and a size can only be applied to the acute angles. And as we expand the trigonometric ratios to the trigonometric function, we had to apply a new concept, unit circle, where we can measure any kinds of angular rotation with coordinates and the trig values. And the last thing I want to talk about is for this measuring this coordinate, first right triangle we could make is this right triangle where I'm coloring with the red color. But people might think that why can't we make a right triangle like this where I'm coloring with the white color? And it is possible, but this triangle, this right triangle to measure the coordinate has a special meaning where I'm going to talk about it in the next video. And in the next video we're going to talk about more special or detailed properties of the ratios, not ratios but the unit circle, including its properties.